continuing on with the note sheet from, well, technically finishing up the notes from yesterday. Most likely we're going to need to finish it tomorrow. It'll take one more day than I was hoping. So no homework today. It'll be all from the new notes today. And I realized, again, I need to fix these note sheets because we're going to look at these here, and unfortunately, they're nowhere in the note sheet. Yeah, somehow they got left out, but I do want to start with this. So if you want to flip the note sheet to the back, it should be completely blank. So we'll have two pieces or two parts of this here. Because the first thing we're going to do is write an interval, each interval in interval notation. Now, interval notation is something that y'all have done before. You've done it most recently in Algebra 1, but that has been a little while since y'all have taken Algebra 1. And the main parts of interval notation is using our parentheses and brackets. So write an interval. So this is kind of coming back a little bit, hopefully. We'll see. So the first one we're going to look at is these two here. Now we use parentheses if it is not included or not equal to those given spots. And we use brackets when it is equal. Because if we say greater than or equal to or less than or equal to, we're using the brackets. On a number line, that would be a closed circle. Not equal to is our greater than or less than. And on a number line, that'd be open circles. Now, as we look at this first one here, I've done this for the first few lessons, and I think it's sometimes helpful, especially seeing it on a number line, is a little bit easier to go to an interval notation than it is to straight inequalities. If you can see, go from inequality to interval, that's perfectly fine. But I'm going to go on and graph it so we see both. Because if we graph this on a number line, we do have two spots where we can put points. We have one at -2 and the other at 3. And in both of these, we're going to have circles. Now, at the point -2, is the circle going to be open or closed? Is it equal to? Yes. Because it's saying -2 is less than or equal to x. Because we have the line underneath it, it is saying equal to, which means this is going to be closed. How about 3? It's equal to, so it's closed as well. And one of the nice things with inequalities is if x is in the middle, we shade in the middle. If x is in the middle, we shade in the middle. And that's one of the main ways I remembered it, especially with and statements. If x is in the middle, we shade in the middle. Because it's saying -2 is less than or equal to x is less than or equal to 3. So it's between those two spots. Questions on how we graph this? Now, if we write it in interval notation, we need our two endpoints. So we're saying it's going from -2 to 3. Now, we are missing one piece because we need the parentheses and brackets and or brackets. So the one that goes next to the 2, would we put a parenthesis or a bracket? Yeah, because it is equal to. Here. And 3, it would be a bracket because it is included. Questions on this here? Let's look at B. X is greater than -1. How many spots can we graph on the number line? 1. And ironically, it is -1. And we can put a circle there. And just like the previous, this one's going to be closed.
No, it's open.
It is open.
Okay, I was
No, it is open because it is not equal to it. It's just greater than. Now, would we shade to the left or to the right?
None. Right?
Left or right?
Right. Left.
Yeah, no, it is right.
Oh,
Oh, wait. I went this way.
Yeah,
I don't know why.
yeah,
Right.
yep. Because it is, you're right, but you're facing the board, so it's the other way around. Because we are going greater than, so it is to the right of -1. So all these values going this way. Now, as an interval, -1 would be one of our points. Now, because it is greater than or less than, it is what we call an unbounded. That means we're going to include infinity or negative infinity. Which one would we include? So which one's bigger, x or -1?
X.
Because x is greater than -1, yes?
Yes.
Opens. So we want all the values that are bigger than -1, yes? So what's going to be bigger, infinity or negative infinity? So we would need infinity. And the infinity would be
Oh, I got opposite.
parentheses. Infinity and negative infinity will always be parentheses, mainly because we can never actually get to infinity. So if infinity or negative infinity is ever included in interval notation, it will always have a parenthesis. Any questions on A or B? The next one we're going to look at is C. C is already graphed for us. Now for C, do we have 1 or 2 endpoints? 2. And our 2 endpoints are? And 4, yes. So if we wrote it as an interval, our 2 points would be -3 and 4.
Oh, never mind, because it does not lead. Well, if it's closed, would that mean it is equal to or?
Yes.
Uh,
So since it's
closed
close,
would be equal to.
yes.
Open would be not equal to, so it's the parentheses.
Right. So closed is equal to, open is not equal to. So since -3 is closed, it means it is equal to that amount. And since it is equal to, we will use a bracket. 4 is the parentheses because it is open. So we have bracket -3, 4, parentheses. And how about letter D? So 3 is one of our endpoints, yes?
Would it be infinity?
Negative infinity. Because it's continuing to the left, it's continuing in the negative direction. And we would say it would go to negative infinity. Now, because negative infinity is the smaller, it goes on the left, the 3 goes on the right. Parentheses around the negative infinity. 3 is the bracket because it is included. Questions on this here? So is this kind of coming back, doing some of these here? Awesome. The next page is also not in your notes. It's not. Do not write all of this down. We're going to walk through this, and it's going to make a little more sense, especially as we talk about this here. Because this right here is set builder notation. It is a specific way to write and describe sets or kind of types of numbers we're looking at. One of the main features that will always be included in set builder notation are these 2 braces. We're always going to start set builder notation with a brace. We're going to end it with a brace. It's going to have two braces. Just kind of like we did with kind of our subsets, having braces on either end. It kind of quantifies that our group or our set is what's inside. Now the first main part is this here, this X. It is describing the types of numbers that we're using. Unless it states it in the problem or whatever we're running to write in set builder notation as integers, natural numbers, whole numbers, we are going to use all real numbers. So intervals, like we were having a minute ago, or inequalities. If we have either one of those to start with, it is understood to be all real numbers unless stated otherwise. And if it is all real numbers, we just do brace X bar. That's all we have to do. And we'll cover some where we don't have that, and those are actually in the note sheets. But if it's just saying all real numbers, we do brace X bar. Now, the bar is actually a representation of such that. So what we've had, if we wrote this so far, is we do brace X bar is saying that the set of all real numbers such that. So X is any real number such that it satisfies the following condition. And this last part really just describes. So if you want to write this part down, kind of what we have here, that will be helpful. Because the first part, so we have brace, and what goes in that first section is kind of describing the types of numbers. If we're talking about all real numbers, we can just leave it as X. If it's something other than that, we have a way to write it, and we'll look at that here in a minute. But we can say X is an element of the integers, or X is an element of the natural numbers, or rational numbers. Such that, and then we have a description to it. Something that's going to describe it. I'm good for right now. We'll go to the next one because some of the A, B might be confusing because it's just two examples that we have. We good with this here? All right, on the back of the first page of the notes. So flip the note sheet over, back of that first page, we're right here. We'll come back to the first page of the notes tomorrow. So the first thing we want to do is write the sets of numbers in set builder notation. So the first one is a set of all integers greater than 5. It'd tell us kind of what type of numbers we're going to look at or working with. All integers, we're talking about integers, yes? Did we have a symbol for this yesterday? It was our Z with a line. So we can use the Z with a line to describe integers because we understand that is its symbol. Or we can actually, there's a way to do it with writing out integer. So that tells us the type of numbers. Do we have any description on what kind of numbers we're looking at besides it being integers? Yeah, they're greater than 5, yes? So this is our other half of it. Now, a lot of times when we're dealing with these here, we can't use intervals. We've got to use inequalities. So greater than 5, we would say what? X is greater than 5. Okay? Any questions on this so far? So the first thing we can do in writing this in set builder notation is our brace. x. So we would use the line, and we could do that, and there's a way to do it. I'm going to show you one way else first, because again, we're not talking about real numbers, we're talking about integers, yes? There is a special symbol that we can use. It looks like an E. This here means element. So x is an element of what? What do we? Because what kind of numbers do we want? So x is an element of the integers, because at this point we're just talking about what kind of numbers are we working with. We're talking about real numbers, whole numbers, natural numbers, integers. So here we're saying that x is an element of the integers such that, yes. And that's it. Now, I did say we could write it out. So we could start off by saying brace x bar for the set of all real numbers x such that x is an integer and I didn't show this in the other hours, but we could say for the set of all real numbers x such that x is an element of the integers and x is greater than 5. Both of those work. All of those are saying the exact same thing. If it just had said the set of all real numbers greater than 5, so this is taking out integers, it would just be this here. Because if we just want the set of all real numbers x such that x is greater than 5, that'd be our statement. But questions on this here? Let's look at the next one. So negative infinity to negative 1 or negative 1 to infinity. As I mentioned kind of earlier, we can't use intervals. We have to have it as inequalities. So the first thing we need to do is change this from interval notation to an inequality. Now, as I've been doing this today, I think it's sometimes easier to see it as a graph, a little bit easier than it is intervals. But if you can see the inequality straight from the interval, that's fine too. Because our one main point from negative infinity to negative 1 is, well, and will the circle be open or closed? Do we have a parenthesis or a bracket? Parentheses. Parentheses, are they equal to or not equal to? They're not equal to, so the circle should be opened because it's not equal to that point. Now from here, do we shade to the left or to the right? Left, because it is negative infinity. And as an inequality, we would say x is what? Greater than or less than? Less than. Negative 1. Or, because we'll bring the or down because we're going to have two statements. It's going to be one or the other. Yes. So for the other one, if we graphed it first, we'd have a open circle. No, you're good. Open circle at negative 1, and we would shade to the right, which would be x is greater than negative 1. So we start out with our brace. We're going to brace ourselves for the start of this problem. Such that, yes, Because did it tell us what type of numbers? Since it doesn't tell us, we are automatically using real, all real numbers. So we don't have to add anything because brace x bar is saying the set of all real numbers such that what? Yeah. That's it. So these are very nice, especially if it starts it off in inequality form. Because if they just given us x is less than -1 or x is greater than -1 from the start, we could have gone straight into our set builder notation. We didn't have to change anything. Questions on this here? What value of this can x really not be? -1, because we're saying that it's less than it, it's true, or it can be greater than it, yes? So the only value x cannot be is for the set of all real numbers x such that x is not equal to -1. These are saying the exact same thing. And sometimes that can be confusing looking at those two, but they are saying the same thing. Question on this here. We ready for the next one? And we'll look at another one just like this here. Is number 6 the exact same as the last one? No, because we have now -1 and 1. Yeah. And there's also a bracket on -1. So there is a massive gap between -1 and 1. So we can't just say it's not equal to one of them. All right. So let's do our number line. So we'd have -1. And -1 would be equal to, and that means it is. Brace means equal to. Equal to means closed. Will we shade to the left or to the right? Yes. And as an inequality, we would say x is or -1 or because at -1 we have the bracket. Bracket is equal to. Yes, the other one would be open and shaded to the right. And as an inequality, we would say what? X is 1. We wouldn't use equal to because it does have a parenthesis. Parentheses is not equal to. So we have these two here, yes? Now, I wrote them side by side. You can write them however you want. So when we write our set builder notation, we would have brace x bar. We both knew what each other meant. And that's it. What do we think of these so far? Different? Yeah, it's just remembering the order. And again, when these show up on the test, you will have the review sheet. You will have the review sheet, put notes down. Because for the most part, especially with set builder notation, this kind of stuff is used not very frequently with what you'll cover, most likely, especially in algebra, college algebra. But if you go into more of a pure mathematics field, just mathematics doing solving proofs, you'll use stuff like this. Another way, and again, you don't have to write this. Apparently, there we go. this is above and beyond the way to say for all real numbers x. There's actually another symbol for it that we can use. It looks like this here, like an upside down A. So this is saying for all numbers x, for all x in the real numbers, because x is an element of the real numbers. So I wouldn't write this. This is way above and beyond. So you just so you're not going back and referring to it. Such that x is less than or equal to -1. And this v is actually another way to say or. If you flip it, looks like a little tent, that is and in proof statements. So for all x in the real numbers, such that x is less than or equal to -1, or x is greater than 1. Above and beyond, but I mean, yes. This is conditional or, because most likely in probably middle school grammar, when you talked about or statements, or means one or the other. But technically, or could be both. I mean, you could technically have both in an or statement, yes? Because one could be true, the other could be true, or they technically both could be true. Conditional or means it has to be one or the, it can't be both. But again, above and beyond. We do have one more. Yeah, I never saw this last one until doing some of the proof-based classes in college. The last one on this slide here, we have the set of all integers except -4. So what kind of numbers are we talking about? Integers, which is our except -4. So with it telling us that it's the set of all integers except -4, it could be any integer except 1. So it's telling us that this cannot equal. So how can we write that x is not -4? Put a line through it, because this is saying it is equal to it. Now it is. No. Well, almost, because we got to write in set builder. Mm-hmm. That was a little bit on the lazy side, just filled it in, filled in the blanks. Because we do brace x, r, e, z. X is an element of the integers such that x is not equal to -4. So it's everything else. Now, if it had said the set of all real numbers except -4, we could have written it like this, because we don't need that element of the integers because it's not an integer anymore. It's part of the real numbers. But that's it with this here. Any questions on any of this here? Not so far? Whole numbers, 50 through 54. So if we were going to list these out, what is the first whole number from 50 through 54? 50, okay. So we can do brace 50, because we're going to list these subsets. What's the next whole number? 51. The next one, 52. Whole numbers 50 through 54. Now, if it hadn't stopped at 54, it just said greater than 50, we could at this point do ... telling us that it's going to continue on in this pattern forever. But since it wants us to stop at 54, We can put our other brace, and we do have the set of whole numbers 50 through 54. And that's it. Questions on this here? Be ready for the next one. All right, so we're going to do a similar thing for the real numbers 0 through 4. So what's the first real number?
What?
Well, we can say 0. I'm not going to nitpick on this because I would say 0. What's the next real number after 0? What about a half? Is a half a real number? Yeah, it's a rational number, isn't it? So it's a part of the real numbers. How about 1/3? 1/7? 9/5? Because 9/5 would be 1 4/5, which is going to be between 0 and 2. How about 0.479? 0.586? 0.7924? Have I even got anywhere close to listing all of them between 0 and 1? There's too many. Actually, the number of numbers between 0 and 1 is infinite. Because we could say 1, because I could say 1 over 2, yes? We could say 1 over 3, or 1 over 4, or 1 over 5, or 1 over 6, 1 over 7. I could put 1 over any of the natural numbers. And how many natural numbers do we have? An infinite number. So I've just for 1 over, but then we could say 2 over 3, 2 over 4, 2 over 5, 2 over 6. Yes. So is it really possible for us to list every number from 0 to 4? Now, some would say this isn't technically correct, but it's what we're going to do for this here. We'll start off with our brace, but instead of listing them, we can write it as an inequality, or greater than or less than, because our first number is x is less than. And that's what I will take for this here, because we have to write it as an inequality since we're talking about the real numbers. I think some would say that we should really write it in set builder notation, brace x bar, 0 is less than x is less than 4, the set of all real numbers x, such that 0 is less than x is less than 4. Questions on this here? Now, if this had said the set of integers from 0 to 4, then we could list 0, 1, 2, 3, 4. And that would be right. Hey, this time we do have integers instead of real numbers. So we can start off, we can see. So we can start off at what? Negative 100, yes?
Yeah.
What's the next number? 99, then negative. Yes. Okay. Then what would we do? Yeah, we can do 97. And then 98, 99, 100. I think I did bring that up yesterday a little bit. Kind of how we can do the dot, 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 and then finish it out. Yeah, because we set a pattern, and then we closed it out. We said that there is a definite endpoint. So we don't have to write it all out because we set the pattern and then finish it. Questions on this here? I think it's about time, yes? And incidentally, this is where we're going to stop for today.